All right, so if you're a developer, I bet you've seen it. That one error message that just stops your deployment dead in its tracks. Well, today, we are going to pull back the curtain on namespace quotas and finally explain the why behind that super frustrating exceeded quota error.
So let's paint a picture, right? You've just finished your code, it's running like a dream on your local machine. You push it, you kick off the deployment pipeline, and you lean back in your chair just waiting for that beautiful, beautiful success message. But instead,
you get hit with this, a 403 forbidden, exceeded quota, and it just feels like the platform is putting up this arbitrary wall, just blocking you for no good reason. It's infuriating, isn't it?
But what if I told you this isn't a bug, and it's not the system just being difficult? It's actually a guardrail. It's an absolutely crucial piece of architecture that's designed to protect the entire system, and yeah, that includes your application too. Let's break down how this really works. Okay, here's the plan. We'll start by looking at this limit as your unseen resource budget. Then, we'll dig into how that budget gets calculated and what that means for your contract with the cluster. And of course, I'll show you how to check your balance, and we'll finish by changing our view of this thing from a gatekeeper to more of a helpful guide. First up, let's totally reframe how we think about a namespace quota. It is so much more than just a simple limit.
You know, the official definition calls it a tool for admins to limit resource consumption. But honestly, a much better way to think about it is like a prepaid utility allowance. Imagine your project is in a shared apartment building. You get a set amount of power, right? And that's based on the building's total capacity, just to make sure you don't accidentally cause a blackout for everybody else.
And, you know, this quote from Soul Repairs just nails it. On OpenShift, quotas create a defined box of resources for your application to live in. This little sandbox is what makes self-service for developers even possible. And it stops one rogue app from taking down the entire platform.
So the big question is, how does the landlord, the platform admin, decide how big your allowance is? Well, it's not just some random number they pull out of a hat. It's actually a calculated architectural guess based on some really key design factors.
see, admins calculate this budget based on four main things: knowing the physical hardware they're working with, using baselines for your specific tech stack, planning for the overhead from your deployment strategy, and adding a little buffer for growth. Let's see how these pieces all fit together.
First, they start with some standard industry baselines. It's just a fact, right? A Java application with all its JVM overhead is naturally going to have a much bigger resource footprint than, say, a super lightweight Go or Node.js microservice. So your initial budget reflects what your tech stack typically needs. Okay, next up, they have to think about how you deploy your app. This one trips a lot of people up. If you're using a rolling update, for a brief moment, the system needs enough budget to run both the old and the new versions of your app at the same time. And as you can see, that effectively doubles your resource requirement during that transition.
And finally, a healthy buffer gets added right on top. It's usually something like 25% over your average peak load. And what this does is it gives you breathing room. It gives you the flexibility to handle those unexpected traffic spikes or really busy days without having to run back and ask for a budget increase.
All right, so the budget is all set. Now, how does this actually affect your day-to-day work? This is where we get into what I like to call your contract with the cluster. When a quota is active, the rules of the game are actually pretty simple, but they are very strict. First, you have to specify resource requests and limits in your pod definition. If you don't, it gets rejected, period. Think of that spec as your contract. The API server then checks if your request fits inside your budget. If it doesn't, that's when you get that 403 error. It is a hard stop. Now, this slide right here is so important to understand. It shows exactly what happens if your app tries to go over its limits while it's running. If you go over your CPU limit, your app won't crash, but it will get throttled, which means higher latency. But exceeding your memory limit is way more serious. The kernel will issue an out-of-memory kill, and your pod, it crashes instantly. Okay, I know this might sound a little intimidating, but here's the great thing. You are not flying blind. The platform gives you total visibility into your resource budget, so you never have to guess how much you have left in the tank. All it takes is one simple command in your terminal, OC describe quota, and with that, you can get a real-time report card on exactly where your namespace stands. And the output looks a little something like this. Look how clearly it lays everything out for you. You can see precisely how much CPU and memory you've used compared to the hard limit you've been given. This is basically your personal dashboard for resource management.
So, let's bring this all home.
Why does any of this really matter? Well, because understanding it can completely change your relationship with the platform you're working on. Quotas stop being this frustrating, mysterious gatekeeper, and they transform into a predictable, transparent system that's built for stability. They are not there to stop you from deploying code. They're there to guarantee that your application, and just as importantly everyone else's, can run reliably on that shared infrastructure.
And that leaves us with one final thought. By making resource definition a mandatory part of the deployment contract, the system is basically pushing all of us to be better architects. Knowing your app's true resource needs isn't just a nice-to-have performance metric anymore, it's a fundamental requirement to even get your code deployed. So, the real question is, how well do you know yours?